Section 6.4 is on rational exponents. A rational exponent is an exponent that is a fraction. Radical expressions can be written with rational exponents and vice versa. So a raised to the power of 1 over n is the same thing as the nth root of a. An example of this, x to the 1/5 is equal to the 5th root of x. A raised to the power of m over n is equal to the nth root of a raised to the power of m. Notice that the numerator of the fraction, the rational exponent, goes on the base underneath the radical sign, and the denominator is the index. An example of this, x to the 2/3 power is the same as the cube root of x squared. The numerator goes inside, the denominator is the index. A good one to memorize is anything raised to the 1/2 power is the same as the square root. So 16 to the 1/2 power is equal to the square root of 16, which is equal to 4. Here's a box from your textbook that talks about the properties of rational exponents. Actually, the properties of rational exponents are exactly the same as the properties of integer exponents. Let's take a quick minute and review those. So a to the m times a to the n. In other words, you're multiplying two powers that have the same base, add the exponents. If you're raising a power to a power, so if there's an exponent inside the parentheses and one outside the parentheses, you multiply those. A product raised to the power is the same as each of those different bases raised to that power. A base raised to a negative exponent is the same as that same base raised to the positive exponent, but in the denominator of a fraction. Dividing two powers, a to the m divided by a to the n, same base, subtract the exponents from each other. And then a fraction or a quotient raised to a power is the same as each of those bases being raised to the power and those two being divided. So in other words, the same properties of exponents that we learned in Algebra 1 also apply to rational exponents. Let's do a couple examples here. Here we have -2 times x to the 4/5 power, and we need to write that in radical form. Notice that the exponent 4/5 only applies to the x. It does not apply to the -2. So when I write this in radical form, the -2 stays the same, and then x to the 4/5, the 5 becomes my index, and the 4 is the power of x in the radical sign. So -2 times x to the 4/5 is the same as -2 times the 5th root of x to the 4th. Next example, write the square root of a b cubed in exponential form. Well, this is the same as the square root of a times the square root of b cubed. So that's going to be a to the 1/2 power, because remember a square root, it's kind of like you have a little 2 in there, times b to the 3/2 power. And I can't simplify that, can't combine those anymore because they have different bases, a and b. Here's a couple more examples. It says simplify each expression. I have 625 to the 1/4 power. I'm going to go ahead and write that in radical form, which means it's the 4th root of 625 raised to the 1st power. And what that is equal to is 5, because 5 to the 4th power is equal to 625. Number 2, I have 2 to the 1/2 power times 32 to the 1/2 power. Remember, 1/2 power just means the square root. So that's the square root of 2 times the square root of 32. I'm going to multiply those two. Square root of 64, which is equal to 8. Those were nice. They came out to be nice integer answers. Okay. Let's take a look at number 3 here. The square root of 3 times the 4th root of 3. I can't combine those because the indexes are different, but I think in this case it would be helpful to write each with rational exponents. So the square root of 3 is 3 to the 1/2, and the 4th root of 3 is 3 to the 1/4. Now I can use the property of exponents. It says that if I'm multiplying powers that have the same base, I add the exponents. 1/2 plus 1/4 is 3/4. Now, because this problem started with a radical sign, I want to make sure my answer is with a radical. So I'm going to turn this from exponential form into radical form, and that would be the 4th root of 3 cubed, and 3 cubed is 27. So my final answer is the 4th root of 27. Number 4, I have the square root of x cubed divided by the cube root of x squared. I'm going to write each of those as a rational exponent. So this is x to the 3 over 2 power divided by x to the 2/3 power. And since I'm dividing two powers that have the same base, I'm going to subtract their exponents. 3/2 divided by 2/3 is x to the 5/6. And because this problem started with a radical, I'll do that for my final answer. So this is the 6th root of x to the 5th power. Number 5, 32 raised to the power of negative 3/5. I'm going to rewrite 32 as 2 to the 5th power. And when I raise that to the negative 3/5, you can see what's going to happen. I'm going to use the rule that says that if I have an exponent inside a parentheses and an exponent outside, I multiply them. So 5 times negative 3/5 is equal to a negative 3, which is equal to, so now I have x to the negative 3, 2 to the negative 3, which is the same as 1 over 2 to the positive 3, which is equal to 1/8. And our last example is the quantity 8 times x to the 15th, all raised to the negative 1/3 power. I'm going to rewrite this as x to the negative 1/3 times, 8 to the negative 1/3 power times x to the 15th to the negative 1/3 power. And I'll simplify each one of those. 8 to the negative 1/3 power, I'm going to go ahead and write 8 as 2 to the 3rd power to the negative 1/3. And then you can see what happens here when I multiply the exponents. I'll get x to the negative 5. Multiplying my exponents here on 2, I'll get 2 to the negative 1 times x to the negative 5. And that's going to be the same as 1 over 2 times x to the positive 5th. So in this section, we took a look at rational exponents, basically exponents that can be written as fractions. We learned that all of the properties of integer exponents also apply to rational exponents. We did a couple examples of turning something from radical form into exponential form and from exponential form into radical form, and then how to simplify several expressions.